When we studied increasing and decreasing functions, we were also able to study relative extrema. While when we study concavity, we can also study something that's called points of inflection. At the end of this lesson, you'll be able to find points of inflection of a function by using the second derivative test. All right, so we're going to jump right into determining points of inflection. Points of inflection are basically the points at which the concavity is changing. So if something is changing from concave up to concave down, that part of the picture would be, that point would actually be a point of inflection. Okay, to find points of inflection, it's very similar to actually how we found the concavity of a function. We're basically just going to be looking at the concavity, and if the concavity changes, then we have a point of inflection. So if I'm looking on this first example, back to one that we had already done, we're going to try to determine the points of inflection. Notice we got to the second derivative chart and we have our values. Well, I notice that my graph is changing from concave up to concave down at the point 1. And you basically will notice if I'm looking at the second derivative changes sign. So I'm going to put right up here at the top of my example, for a point of inflection, something will be a point of inflection if f double prime changes sign. For this one, we really don't care whether it goes from positive to negative or negative to positive. As long as it changes sign, we know that the graph is changing concavity. So on this one, since we notice that f double prime is changing signs at x equals 1, we have a point of inflection at x equals 1. And the reason that it's a point of inflection is because f double prime changes sign. And that's all we need to put for our explanation. We know technically because f double prime changes signs, the concavity changes, but that's all we need to put for our explanation. Okay, let's take a look at example 2. Notice we went straight to the second derivative chart to help us tell our concavity. And notice we did find that our concavity changes. And if I look at my chart, I notice that at x equals pi, my f double prime changes signs. So I know that there's going to be a point of inflection at x equals pi. And the reason that that's a point of inflection is because f double prime changes sign, which means that's where my concavity is going to change from concave up to concave down. All right, let's look at that third example. Again, we started with the function. We found where it was concave up and concave down based on the second derivative chart. So I could go ahead and I notice that at x equals 1/2, again, my signs change. So I can say that there is a point of inflection at x equals 1/2, and the reason that that's a point of inflection, once again, is because f double prime changes sign. Okay, one just real quick thing I'm going to point out, if my f double prime chart looked something like this, and there was a negative and then a negative, what I would do on this one, I would say there are no points of inflection, and that would just be because f double prime does not change sign. Something might be happening at 3, but this graph is staying concave down the whole entire way. So hopefully now you know how to find points of inflection using the second derivative test.